Hi viewers, this is Dr. Gunamani Jana and I am working at Roland Institute of Technology. In this video, we will be covering encryption algorithm. Especially, we will be focusing on the AES or the Advanced Encryption Standards. We know the different type of cryptography. First is the classical symmetric cipher, that is the CGR. Second is the modern symmetrical algorithm like DES and AES. Third is asymmetric cipher, that is we are using the public key and private key. Public key we are using for encryption and the private key we are using for decryption. And the fourth one is the one-way hash function, what are we are using MD5 or SHA. In this video, we mainly focus on this advanced encryption standards. This advanced encryption standard or AES, it was established by the US National Institute of Standards and Technology, NIST, in 2001. And this AES is also it is adopted by the US government and it is now used worldwide. Prior to this, it was DES or Data Encryption Standard, which was published in the year 1977. And this algorithm described by AES is a symmetric algorithm. So meaning that the same key used for both encryption as well as the decryption, right? So we use here a block cipher. So these are the key things. And here in this encrypts, AES encrypts messages in block of 128 bit. Because we are having options, we can go for 128 bit, a 28 bit key, 192 bit and 256 bit. 128 bit is enough. It is difficult to decrypt or hack these things till now. But if you need more secure, then in that case we can go for 256 bit. But the reason in that it will be very slow. The algorithm will be very slow. It takes a lot of time, right? So till now, 128 bit key is enough, and the number of rounds required it is based on the key we are using. Actually, there is a formula. If you see here, this formula will be using. That is for yeah, I'll be giving this formula. The number of rounds we will be using NR, which is equal to 6 plus maximum of NB and NK. NB that is the number of bit we are using in the block data, and NK is the number of bit we are using in the key. Suppose it is 32 bit, 32 bit. In that case, it will be 32 bit. 32 bit means it is 32 4 byte. So 6 plus 4, NR will be 10 here for the AES, right? So if it is more, say in that suppose it is we are using 48, 6 into 8, 48. Okay. So 6 plus 6, it will be 12 here. 12 number of rounds will be there. Similarly, 6 plus 8, it can be 14. So this is how the round is decided. So we summarize like this. If it is 128 bit key, then 10 rounds will be there. If it is 192 bit, 6 plus 6, 12 rounds will be there. If it is 256 bit, so 6 plus 8, 14 rounds will be there. This we remember. Then this block cipher, what we say, how it works. Suppose the original message we want to encrypt. What do we do? We get that message, that is the ASCII, what are the numbers? Say for example, once upon a time there was a great king who had a beautiful queen, whatever the things message we want to send it. So this initially it is converted to the binary number, then it is converted to the hexadecimal number, HEX. And after that we convert into some blocks. You can see, so 8 bit makes a byte. 8 bit. So 4 byte of data will be there. So 4 into 4 like that would make it some blocks. Okay. So now we understand the basic structure of the AES. First we take the plain text. This plain text we go for the adding the hard round key. I will explain that one, what happens there. Then we apply the number of rounds because if we are going for 128, minimum 10 rounds will be there. So first round it is that is the only adding the round key. Remaining 9 will be there and the last one will be there. So because it is 10, 9 will be there. We'll be applying this thing and the 10th will be there. What is the operations you can see? One is the sub byte, one is the shift rows, then mix columns and R round key. So this will be there out of these 10 rounds. For 9 rounds, the same operations will happen. And the last one, you see, the mix column operation is not there. Okay. So that is the things. And finally, what we find? We find the ciphertext, right? So this exactly what happens in the entire operation. Now, this is you see in the third round, what we do? We say suppose I am having 128 bit of data. I call it the script, right? Then I have the cipher key that is also 128 bit, right? So this initial key, what I take the key as it is, and this we go for operation. That we go for the explicit or with all that one. Do that I will explain in details. The remaining, because what is the key we get, we go for the expansion of the key because for each round a separate key will be generated, and this key generated out of that one. Some operations will be there. So I will explain that operation in details. So first we are going for round 0, then we go for the round 1, like that. We go for that and finally we get the final round. Then in that case, while we'll be converting these numbers, then we'll be using the S box. AES S box is there. That also I'll explain. So this we can get it even if you go to the internet and ask AES S box and inverse S box. So this data is available. There is nothing rocket science here. So suppose it is for uh, 38. So 33 it is here. You can see here. This is the line here coming here row, and 8 it is coming here. So for 38 it will be replaced by 07. Okay. How it works that will explain here. Now come here. Let us start here. What exactly I was explaining? Our plain text, what is to be encrypted, that is 128 bit. I convert to 128 bits, or we can say 16 byte, okay, 444 like that. So 128 bit block of data we convert. Okay. So M1 128, 128, whatever the things are we convert to only 128. We cannot take more than one because we declare it now that size. So in that case, how many there? We see that it is a block of 128, 128. Then I declare a key, this green, whatever you see, the brown color, what is the data, M1, M2, M3, the plain text, I put it there. And this green color, what we see, that is a key, I put it 128 bit. So this block is 128 bit and this key is also 128 bit. Now, then we'll go for the key generation. Suppose sub key 0 is the same key as it is, we put it here. And this sub key uh, is applied here. We also call it the rank key. Also, we call it the round key, not rank, round key. So this round key, along with this plain text, we are going for the exclusive operation, XOR. Okay. So then output is also coming 128 bit. Then what we need to do, we have to expand the key and we have to generate sub key 1 because 10 rounds are there. So 10 number of sub keys we have to generate. And how do we generate the sub key also, that will take. There is nothing to worry at this moment. And this key, sub key 1, is applied to this round 1. Sub key 2 is applied to round 2. This output is coming here, sub like that, like that. The sub key 10 will be applied to round. And at the end, what we find, that is the ciphertext. That means plain text was suppose something what we can understand. And ciphertext, what it is there, something changed, one immediately cannot understand the meaning. It cannot understand. Now, what happens in this key expansion? Actually, I have taken the reference from this internet. It is not the things research I have done. Maybe some professors they have explained all the things. It is only to explain the students. It is not a new or original content of mine. So suppose the key text here, it is something like that. It is given. This is the key. Key is just like a password. Okay. If you count it here, 1, 2, 3, 4, like that, it is 16. And every letter or the text what is there here you find, they are represented by 8 bit. Say S is represented by something like that. So 8 bit it is represented. Okay. So similarly, all the 16 into 8, so it is 128 bit it is represented. So that means for every letter we are using it here, it is represented by 8 bit. Okay. And this 8 bit, this is the binary representations. And this you are going to convert to a hexadecimal number system. So if you see the first 4011, so it is 1, 2, 3, 4, 7. So like that, the second you find, it is 0, 1, 1, or double 0, 1, 1. Double 0, 1, 1, it is again 3. Like that, the first 8 bit is represented by the hexadecimal number system 73. Similarly, second by 61. Like that, whatever the 128 by 8, it is 16 number of hexa numbers are there. Is it clear? Now, you got it now? So, the same thing, suppose you want to check it, applying the reverse one, you can find the same key or the password, what I have given from the hexadecimal number also, you can get the same thing. Is it clear? Now, once you find this, uh, the key which is converted to hexadecimal number system, you convert to some block. In this block, what you do, the first four, 1, 2, 3, 4, they become the word 0, column 1, right? Like that. So 73, 61, 74, 69. So like that. What is that? So 1, 2, 3, 4. That is B1, B2, B3, B4. It comes here, the first column. Then B5, B6, B7, B8, it comes here. So like that, the entire block key is represented by a block here. Is it here? Up to this, it is fine. Now, what I told that we are going for the key expansion in AES algorithm. What is the key expansion? Because for round 0, we applied, if you see it here, we applied the round key. That means the key as it is. And as it is, what are the key? As it is, this was the key. Okay, 73, 61. Same thing, I am putting it as the key. 73, 61, 74. So this is the key. This for the round key. But while I am going for this round one, how to generate and what are the keys will be there? The keys will be there because the first keys are represented by here and we name it as word 0, word 1, word 2, word 3. Like that, the remaining four will be W4, W5, W6 and W7. How do I generate these things? How do I generate all the things? Right? Because this including the first round or including the round, so there will be 10 plus 1, 11 rounds will be there. 11 into 4, 44 number of words to be created. 44 means if I'm starting from 0, it is 43. So total 44 because 4 is there, that is the round key what I have given it there. So that is there. Remaining 40 you have to generate. How do you generate all the things? That is the things. So for that, this is the first key or the round key, whatever I say, W0 to W3 is given. And we are going to generate or we are going to expand the key for the round one, what is the key I have to generate? Just like a block like this. And round two I have to generate, round three I have to generate, up to round number 10 I have to generate, right? So we will try to understand one key generation in the key expansion. Once you understand one, same thing is applicable to all. What happens here? Here, we apply a function g. What is that function also I am going to explain you. So g of W3. What is W3? W3 72, 69. All the things are elements are there. This. So this g of W3. What is the value? It comes here, the output. And we make it exclusive or with the value of W0. See here. W0, what is there here? 73, 61, 74 and 16. Try to understand. So G of W3, that means this is the different words. So G of last word of this block W3, when we go for exclusive or with the first word corresponding values, and what we find that becomes W4 for us. Try to understand these things. So one time G of function is applied. So then what we get, the value of W4, that is there. Now I go for the W1. What is the value of the W1 here? Then what is the value we got it for W4? W4 is made exclusive or with this W1 and I get W5. And what I get W5, the W5 make with the exclusive or with the W2. So like that, if you understand, W4, W5, W6, W7 is great. Is it clear? So this keyword will be used. This is used for round 1. Round 0 already this is the key as it is. For round 1, this is the key to be generated. Key to be there. Okay. So what the round 1 will do? See round 1, what are the key we are getting here? The round 1, what are the key, the sub key 1 we are getting? What is the output of this one? Output of this one, we have to operate on this sub key 1. Okay. Same thing happens here. Now to understand 4, 5, 6, 7 is completed. Then we have to go for this say 8 1. How to go for this 8 1? See, I take the function g here. I take the function g and then what I do g of w7 because these things already we found it applying the formula in the round 1. Okay. So this g of w7, what is the g function? I'm going to explain nothing to you at this time. So G of W7, what you get, that you make exclusive or with the W4. Okay, what you find W8. Okay, that I show it here. Again, I'm telling G of W because what I have done for this first one, same thing will be done here also. You see G of W7 function of all the things. We go for exclusive or with the WR, we get W8. Okay. So like that, what is the output in this? What will be the W8? This W8, this W8 will be exclusive or with W5 and what is the output? That will be W9, then W10, W11, all things we get it like this. Uh, Then the question comes, what is that function G and what happens in that function? See, for that function, what I have given you that some rotation is there and some things is there. Okay, them there. For the rotation, what you do, I am going to do it here. Suppose initially my W3 is 72, 69, so all things are there. So what is the W3? It is here. W3, this I am applying the function G on this W3. But W3, what are my elements are there? 72, 69, 6E and 67. See, two things are there. In the function G, what we do, this 72 comes down and the remaining are shifted up. It's just like a function like this. This will come here and the remaining will go up. It means first it comes 69, then it comes 6E, then it comes 67 and 72 comes down. Is it clear? So this we call it as the word rotation. ROT, what means the rotation of this word, it is done there. Okay. So this is part of that G function. The second thing we go for the substitute. Substitute the word. How you substitute this function? See what we get it here because it was there initially. The 72 has come down. The remaining shifted to there. So for this 69, there is a corresponding value in the lookup table or in the table. In the table is there. Where you get this table? The A is what is this? This box. This you can get it from internet anywhere. You can get it there. Say from this you can clearly understand. For 69 means 60. So 0, 1, 2, 3, 4, 5, 6. You can get it 6 here. Okay, 4, 5, 6. Okay. So this is the row. It is for 6. Then you want for 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Whatever things you get it here. So these horizontal and vertical where they meet, that becomes we find F9. Okay. So from this S box, the table for 69, what is the substitute word? F9. For 6, it is 9A. For 67, it is 85. And for 72, it is 40. Is it clear? So this is the things what we got it there that I am showing it here. So this was there and this is the Y value I got it there. Okay. Now in the key expansion, another things is there. We go for the exclusive OR of this Y1 with a round constant. This round constant because round 0 nothing to worry because the key as it is you are putting. and we have 10 number of rounds because it is a 128 bit key. So round 1, there must be some constant. Round 2, there must be some constant. For each round, a constant will be there. This constant it is given for round 1. The first is 0 1, remaining 0 0. The round 2, second is first is second, remaining 0 0. For round 3, it is there. It is given there. Now what we do, I am telling, whatever the output we get, the substitute word here, this is to be exclusive or with these values. Then what is the meaning of these things? F is represented, this is the Y1, F is represented by the hexadecimal number system by 8 bit. Similarly, 9 is also represented by, F is represented by 4 bit, and 9 is also represented by 4 bit. Okay. So this is the hexadecimal number is converted to binary number system. And this R1, what is there? 0 1. So 0 is converted to 4 bit 0000, and 1 is converted to 4 bit 0001. Right? So this is Y1 and this is R1. You see, this is only operated on this 0 1. Remaining all are 0. Nothing to worry about this 0 0. All are 0. All 8 bit 0, all 8 bit 0, all 8 bit 0, like that, like that. You know what we do? We have to find the G of W3. In the G of W3, what happens? What is this Y1 and R1? Go for exclusive OR. Exclusive OR operations, if any of the input is 1, if any of the input is 1, then output will be 1 only. If both inputs are same, either if it is 0 0 or it is 1 1, the output will be 0. Okay. So in this case, we find the G of W3. Is it clear? This G of W3, what we get it here, if you come back here, what we are trying to do it here, I'll tell you. This G of, yeah, not here. Hmm. This G of W3, we got it. So in these things, whatever things we got it there, we have gone for one rotation, we have gone for substitution, and then we have gone for exclusive or with all the things, whatever that is the become new word W4. Okay. And this W4, what is there? Again, I will show you what happens there. What is the W4? When we go for exclusive or with W1, that becomes W5. What is the output W5? You get it. This W5 exclusive or with it W2, that it becomes all like that things happen. Okay. So this what exactly, and if you try to write an equation for that one, how we get this W4? W4 is G of W3. We apply this, what I told you, that same X1 we get, and from that Y1 we get, and find the substitute, all the things I tell you. Okay. X1 what happens? Rotation. And Y1 what it happens? We are going for the substitute of that word. From this, look up table. So in that case, what we find, we go for the exclusive or that one, and we exactly find all the things. Now, everything we got it there. So key expansion algorithm also is done. Now, the entire thing up to this we have completed. And now, if you try to find out what we get out of the G W3, it is coming like that F8, it is not capital lowercase, F8, 9F, 85, 40. Right. So, the same thing now, I'm telling you, this W0, what are there? W0, it was 73, 61, 74, 69, like that. So that is converted to binary number system. And GW3, we got something because this W3, after going for all these operations, we got thing. So what is the result? Because we have go for the exclusive one, so we get all the things. If both are different, it is 1. If both are same, it is 0. This result we got it. Then every 4 bit convert to the hexadecimal number, it is 8B, FE, F1, 29. So it happens here. Okay. So this you have to go for the different things. And finally, after what you get it here. So I got the, we are talking about the key expansion. Okay. So the entire thing you can see in some violet colors. 8B, FE, F1, 29. These things, what you got it here? 8B, FE, F1, 29. Second one, F8, something like that. What is it? F8, 96, 92, 90. So the entire key we get it here. So initially the key was there, round key. From this, the round one key generated. The same way, round two key will be generated, round three key will be generated, round three, because we are having 10 number of rounds, all the keys will be generated. Okay. So now we have gone for the key round key, and the expansion of this key. How key 1 is generated, key 2 generated, sub key generated, then number of keys have generated. Our job is not only to create keys or sub keys. Our job is to encrypt our data and decrypt that one. Suppose the data I am sending some secret message now. Secret message now. This is the data. I want to send it and I want to encrypt that one. So this is, you see, the 16 number of letters are there, and I have to represent by 8 bit, 16 bit, 128 bit. Okay, my block of message is 120 bit, and the key also I provided, it is also 128 bit. Right? I don't have a problem. Now what I did, this I converted to, every letter I converted to 8 bit of binary number, and every 4 bit I converted to the corresponding hexa means it is 2 to the power 4, it should be 16. Starting from 0, it will be 15. 15 is F. Okay. You know all the things. 0 to 9 is okay. 10 is A, B, C, D, like that you can get it. So this, again, it is converted to the number system, hexadecimal number system. This hexadecimal number system, what we get, that I convert to a block because this is working on the block cipher, no? So 73, the first 4 converted to one column. It I said W0 or whatever things. 73, next 65, next 63, 72. So my message or data to be encrypted, it is there. Then the key, what the key I generated, because this is round 1, I'm going. If it is a add round key, the key will be as it is because this is the first time we are putting add round key will be this one. So after all the things, while you go for the exclusive bar, you can easily do the exclusive bar. Suppose after the exclusive bar, how do the exclusive bar I'm telling? If it is 73, 73, the result will be all 0, 0. Because if all are same, it is 0, 0, it is also 0, 1, 1 also 0, because it is 73, 73, whatever the binary representation, both will be same. So while you go for exclusion, output will also 0, 0. The remaining we go for that one and we find some number. And what is the output it is coming? What is the output it is coming? Where the output comes? The output comes here because round 0, what is the output is coming here? This output, what it is coming, that is operated with the sub key number. This is sub key, for example, 1. This is sub key 2. Like that. This is sub key 0. Sub key 0 means it is the key as it is. This is sub key 1. So we have gone for this operation expansion, right? So once it is done, then we got all the things. So like that, we can go for all things, and the entire thing you see it here, the same process is repeated in 10 rounds. And finally, what the output we get it here, we find the ciphertext. Clear? Is it clear? So first of all, we have taken the key and we put the round key, try to put it here and gone for some operations. Second thing, we are going for generating the sub keys by expanding the key. And finally, we operate on the message, what is the text message I given on that one. And finally, going through the 10 rounds, we find the ciphertext. Okay. The opposite we do, from the ciphertext, we can get the plain text. So this exactly what happens inside the AES algorithm. And I think you have any doubt and anything, you can send a message or mail to me, also. And thank you for watching this video. If you like, please share it to others. Thank you.